You can see the business.
You gotta hold it steady.
It must be limestone. Actually, there are some layers in here, brown ones, that are probably dolomite. The magnesium has replaced the calcium. That's how dolomite forms. So this was a shallow, occasionally hypersaline shelf sediment. This is shallow water. Very much. This is Florida Bay, basically. This is exactly the same as what you see today in Florida Bay. A tropical or subtropical, shallow, very shallow ocean. It's shallow enough that in hot, dry weather, it actually gets very salty. And it's the magnesium in that highly salty water that changes some of it to dolomite. And from here to the ridge off in the distance is all carbonate rock, because this is the bottom of the Paleozoic, and in the bottom of the Paleozoic there were no mountains here. This was the edge of the continent, and there hadn't been any mountains since back when that gneiss back there formed. So there wasn't any source of clastic sediment, and instead you got all the carbonate. Then at about 475 to 450 million years ago, you had the first collisions off on the side up to the east. That raised up a mountain ridge called the Taconic Mountains. It started providing a big source of clastic sediment, and the clastic sediment washed inland, covered over the carbonates, and gave you a thick section of shale and sandstone from then on. Then it stopped. Those mountains wore away back down to where they weren't providing sediment anymore, and you had more carbonate being deposited on top. Then 350 million years ago, Madagascar, or a chunk of continent the size of Madagascar, hit up to the northeast in New England and the Maritimes. Same thing again. You had a local Himalaya mountain range providing a flood of sediment coming in. Although the mountain collision was to the north, it was big enough that there's a thick batch of sediments in here. And if you drive west on this road, you'll find those sediments next, overlying the carbonates again. Those mountains wore away. No more mountains. More limestone coming in. We have a third layer of limestone, and then Africa hit. And the flood of sediments went all the way to the Mississippi River then. Covered all of the eastern half of the country. Those are the coal beds. Those are the coal strata that you find all the way across into Ohio, Indiana, and Illinois. Carbondale, Illinois, is in those sediments. Carbondale because of coal. So this tells us it was quiet here. There was nothing going on here. Okay, now, the one thing I want to really show you here, though, this chunk of rock right here. It's a different limestone here. Actually, I never did test it to see that it's limestone, so let me check that it is still. There we go. My identification was correct. It is limestone. But it's obviously a slightly different limestone, thicker beds than the one around here. That was taken from somewhere else, exactly where I have no way of knowing. I'd like to talk to the geologist who mapped this spot, because he might be able to say, oh, that looks like so-and-so rock. I don't know. All I can tell is, just looking at this, is it was broken off from somewhere else, carried out here into that shallow water bay, and dumped right here, compressing the rocks around it, compressing the soft mud around it. This was solid at the time. The rocks around here were soft. And then more was draped over it. So this is what's called a drop stone. There are several ways to do this. One way to do it is with floating ice. The ice carries the rocks out, melts, and drops the rock. This was tropical at the time. It's not an ice rafted dropstone, almost certainly. Another way to do it is tree trunks that grow around a rock. The trees fall down, the rock is still held in the roots, drifts out to sea. There weren't going to be any trees for another couple of 100 million years. So it was not tree roots. As a matter of fact, at the time, we don't know that anything was living on land. If it was probably mosses and lichens and nothing bigger. So it's not a tree root dropstone. Volcanic bombs will do that. Toss it up into the air and it flies half a mile. That ain't volcanic rock. So it's not a volcanic rock dropstone. Damned if I know. I do not know how that thing got there. Of course, I'm not an expert in sedimentary rock geology. I'm not a sedimentologist. And it might be